Our last formula that goes along with finding sides and angles of triangles is our law of sines. Law of sines is like law of cosines, where it can be used in any triangle, acute, obtuse, or right. So you might want to make a note of that. So it can be used in any triangle. And let's go ahead and look at our IB formula booklet and see what it looks like in there. So here's the booklet. On the last video, we did law of cosines, or the cosine rule. So the law of sines is here. If you had geometry at Ozark, we did do the law of sines in geometry. And I'm going to write that down on my paper. A over sine A equals B over sine B equals C over sine C. What's important for this formula is that the letters top and bottom match. So A over A, B over B, C over C, okay? They have to match. And we can pick any two of these depending on what triangle we're working with, depending on whether we need to use A's, B's, or C's. For this formula, we can use this for angle, angle, side, angle, side, angle, or the SSA triangle. But this one sometimes gives two answers. The IB will not give you a question where it gives you two answers. I just want you to be aware that if you're using this to solve a problem, like out in the real world or something, you got a triangle, you're trying to work with it, that it could give you two answers, but the IB for math studies will never give you one that gives you two answers. It only gives you the ones that give you one. So we won't worry too much about that in here. All right, so how do we use this formula? Well, let's do an example. I'm going to do an obtuse triangle here. And that's what I'm working with. I'll label this as B and this is C. We want to find this side. All right. So a couple things. If we needed to find, let's say, angle B, we know that the three angles within any triangle add to 180. So we could take this and this away from 180, and that would leave us with angle B. So that's something else we could find in this triangle. But we want to find this side across from A, so just like in the last lesson and the one before. So in order to label your triangle, across from angle A is side A, across from angle B is side B, across from angle C is side C. We always have to use, when we do sine, for one of our fractions, we have to know both things. So we either have to know both A's, both B's, or both C's. So in this question, we know both C's, because we know angle C and side C. In order to use the sine ratio, we need to know both of a letter. So we know both of C's. So I definitely want to use my C's because I know both of them. So I'm going to pick my C fraction from above. That's this one, the C fraction. I'm going to use C over sine C. Definitely want to use that one because I know both C's. Now what I want to find is A, so I want to use the A's also. And I know one of them, trying to find the other. So I want to use my A's. We're going to plug everything in. So C is 11. Angle C is 48. Side A is what we're trying to find. And angle A is 115. So we plug in everything we know. When you get to this point, you should only have one variable, and there it is. If you have more than one variable, then you need to reevaluate the choices that you used. Okay? But we have only one variable, x. A couple things we can do from here. So if you like cross multiply, then you are welcome to cross multiply here and here and go from there. Additionally, we could actually find this fraction. Okay? I'm going to find my sines. Let's see, going to find my signs in my calculator. You can solve this fraction lots of ways, but I'm going to find sine of 48, and that goes on the bottom of this fraction, 0.7431. I'm going to put a couple extra decimals just because I'm going to have two of these, so I might not be able to directly use it. Sine of 115. Okay. Now we could actually divide those numbers. On the left side, and this is 14.80196 equals x over that long decimal. Now, because x is being divided by that decimal, in order to solve for x, we're going to multiply. So remember, you multiply over by whatever's being divided. Oops, 9063. I'm going to use the entire decimal that's here, times, and I'm going to use the longer one. It's also above right here in my calculator so I can see the whole thing. 906307787. And x is alone on that side now. And 366, 13.4. Look back at our unit, centimeters. That found the information that they wanted us to find. So we chose to use the C's because we knew both of the C informations, angle and side. We used our A fraction because we wanted to find side A and we knew angle A. So at this point we had only one variable. You can figure out what this is in your calculator. You could have done that all in one step and gone from here to here. Okay. Figure out what sine of 115 is in your calculator. And then multiply this over to solve for x. So that side is 13.4. It's always good to think, does my answer seem reasonable? That seems reasonable. This one was 11. 13.4 is not that much longer. It is across from a bigger angle, so it should be a bigger side. This one's across from a smaller angle. So 13.4 seems reasonable. Now we can use the law of sines to also find angle measures. So we're not just restricted to finding side lengths with it. So let's see how we could use it to find an angle measure. So we're going to find the measure of angle A. Okay. So here's our little triangle. We want to find angle A. So to do this, we are going to use the law of sines. We've got a pair of information we know. We know B and side B. Remember, A is across from A, C is across from C. So we know both angle B and side B. So when we set up our sine ratio, we want to make sure to use the B's. B over sine B. And the A is what we're trying to find. So we want to make sure to use the A's from our fractions. So we know both B's. So we know side B is 13, angle B is 42, side A is 7, and we don't know angle A. So that's our setup. Just like in the last example, we could type all of this in, because it's a number over a sine of this. We could type all this in and figure out what that is. Also, we only have one variable. Number, one variable. So this is a good setup for law of sines. I'm going to type this on the left side in. So 13 over sine of 42 is 19.428195. On this side, we can't figure out what this is because we don't know angle A, and the 7's stuck on the top. So you always, when you're solving an equation with a fraction, and you need to move this side, you're going to multiply by the thing on the bottom. So the sine A is on the bottom. So we get sine A times that. The sine A's cancel. And in our next step, we divide off the decimal. I'm going to move up here. So what we did here is we multiplied by sine A because it was being divided. Put it over here. Then because it's multiplied, we divide off the 19. And sine A is equal to 7 over 19.42, yada, yada, yada. So 7 over the last answer, 0.3603. Anytime you have a ratio, like sine, cosine, or tangent, you got to equal to a decimal. You're trying to find the angle, you've got to go backwards. So you want to find your angle from the decimal, you go backwards. So to do this in our calculator, we type sine of -1, which is inverse, of the decimal, and that will give us the size of the angle. So in my calculator, second sine of the decimal, using my last answer, so it's not rounded, gives me 21.1 degrees. Okay, we look at our triangle and make sure that that seems reasonable. Triangle is not drawn to scale, however, this is a reasonable measure for an angle within a triangle. Additionally, 7 is smaller than 13, even though it's not drawn that way, so this angle should be smaller than that angle, and it is. 21 is smaller than 42. Seems like a reasonable answer. So whenever you get to your homework for this 15H, make sure that if you're trying to find a side length, you follow these steps here. If you're trying to find an angle measure with the law of sines, you follow these steps here. In the next lesson, 15I, we're going to put all of this together, and we're going to have to start trying to figure out when to use which rule. So when to use cosines and when to use sines, because we can't always use either one. We can't always choose, so we're going to start trying to figure out how to know when to use which one. Thanks for watching, and let me know if you have questions over this.